You wanted a clean engine bay so badly you could already picture it, that satisfying moment when you lift the hood on a Saturday morning and see every plastic cover gleaming, every hose looking factory new, every inch of that mechanical landscape pulled back from the grimy neglect of 50,000 road miles. And so you did what every YouTube thumbnail and every auto parts store end cap told you to do. You grabbed the heavy duty engine degreaser, you followed the directions, you sprayed it deep into every corner, you hit it with pressure, you foamed it up until the whole bay looked like a bubble bath, you rinsed it down, you stood back, you felt proud, and then you closed the hood, sat in the seat, turned the key, and heard the single most gut wrenching sound a car owner can ever experience, which is nothing, or worse. The sound of your starter spinning freely while your dash erupts in a constellation of warning lights that your brain registers one by one with increasing horror: check engine, battery fault, throttle position sensor error, camshaft correlation code, and you sit there in your driveway with soap still drying on your knuckles, wondering how a clean engine became a dead engine in under 20 minutes. And I am going to tell you exactly how that happened, exactly who profited from it, and exactly what the $1 solution is that every professional engine technician already knows about, but the detailing industry has spent millions of dollars making sure you never find out, because the moment you learn this, you will never spend another dollar on engine bay cleaning products for as long as you own a car. The engine detailing industry is one of the most cynically engineered consumer traps in the entire automotive aftermarket, and I want you to really absorb what I am about to tell you, because this is not a minor quibble about product performance. This is a deliberate architecture of misinformation designed to sell you a chemical solution to a problem that does not require chemistry, while simultaneously creating brand new mechanical problems that require expensive professional intervention, which the same industry ecosystem profits from through diagnostic tools, replacement sensors, and corroded connector repair kits that you now suddenly need after following their instructions to the letter. Walk into any auto parts store and look at the engine cleaner shelf, and what you see is pure theater: heavy-duty engine blasters in orange and black cans with pressure nozzles engineered to shoot foam 6 inches deep into your engine bay, industrial-strength degreasers with graphics of engines so clean they look machined yesterday, pressurized steam cleaning kits marketed to the home detailer as the ultimate solution for grease and grime, and every single one of these products shares a common design philosophy, which is maximum chemical aggression and maximum fluid penetration. And both of those properties are catastrophic for a modern engine bay, and the manufacturers know it, and they sell it anyway. Because the warranty on your car expires before the damage becomes visible, and the damage, when it finally surfaces, looks exactly like an electrical fault and not like something you sprayed into your own engine on a Saturday morning 6 months ago. The safe alternative is not a secret, it is not proprietary, it cannot be patented, and it costs approximately $1 for enough supply to clean your engine bay 50 times, and that is precisely why it has been buried under 30 years of aggressive product marketing. And that alternative is a solution of pure distilled water and a single drop of mild baby shampoo applied exclusively through a damp microfiber cloth, never through a spray bottle aimed at the engine, never through a pressure nozzle, never through foam, but through direct cloth contact only. And the chemistry behind why this works and why it is safe is so straightforward and so elegant that once you understand it, you will feel a very specific kind of anger toward every brand that sold you anything else. Hit subscribe right now and join the garage resistance, because what I am about to break down for you is the kind of information that the detailing chemical industry needs you to never fully understand. And every person in your contact list who owns a car needs to see this video before they open a can of engine blaster and cook their own electrical system. Before I give you the exact protocol, you need to understand the actual engineering physics of what is happening inside your engine bay when liquid contacts it, because this is the knowledge that the product labels deliberately omit. Your modern engine bay is not a metal box full of mechanical parts that tolerates liquid the way a cast iron pan tolerates water. It is a dense network of precision electronics, and I want to give you specific examples so this lands with real weight. Your variable valve timing solenoids are bathed in oil pressure signals and controlled by pulse width modulated electrical signals from your ECU, and their connectors are sealed with tiny rubber O-rings inside the plastic housing that are engineered to keep atmospheric moisture out of the copper terminal pins. Your crankshaft position sensor and camshaft position sensors sit in physical proximity to spinning metal components and are exposed to heat cycling hundreds of times over the life of the vehicle, and their connector seals are already under mechanical stress from that thermal expansion and contraction. Your throttle position sensor, your mass airflow sensor, your NOx sensors, and your oxygen sensors are all connected through wiring harnesses that run across the entire engine bay, and those harnesses pass through grommets in the firewall and along plastic routing channels that accumulate exactly the kind of light dust and road film that makes an engine bay look dirty in the first place. The reason tap water is dangerous near these components is not merely because water conducts electricity in a general sense, it is because tap water carries dissolved mineral ions, primarily calcium, magnesium, and chloride. And these free ions are what make water electrically conductive. And when tap water evaporates inside a connector housing or along a wiring harness, it does not take those mineral ions with it. It deposits them as a thin crystalline residue directly onto the copper terminals, and that mineral residue is hygroscopic, meaning it actively pulls additional atmospheric moisture onto the copper surface, and over weeks and months, this creates an ongoing electrochemical oxidation reaction that silently corrodes your terminal pins from the inside of a sealed connector that you cannot open without destroying the weatherproofing. Distilled water has had those mineral ions removed through the evaporation and condensation process of distillation, and in its pure starting state, it has extremely high electrical resistivity because there are essentially no free ions available to carry current, which is why it is used in laboratory electrical testing and in battery maintenance. But here is the critical distinction that the products on that store shelf want you to miss entirely. Distilled water does not stay pure the moment it contacts any surface, because the instant it touches engine grime, oil residue, rubber compounds, or even the mild surfactant in baby shampoo, it begins acquiring ionic character from those dissolved compounds, and its resistivity begins dropping. This means that the safety of the distilled water method is not derived from spraying distilled water near electrical components and trusting its purity to protect you. The safety is derived from the application method itself, which is cloth-only contact that introduces controlled minimal moisture to plastic covers, valve cover surfaces, intake tract exteriors, and engine dress components only, with immediate hand drying so that no standing liquid exists anywhere in the engine bay long enough to migrate toward electrical connectors or pool in recessed areas. The baby shampoo contributes a non-ionic or mildly amphoteric surfactant that reduces the surface tension of the distilled water solution, allowing it to lift dust and light grease from smooth plastic and painted surfaces without the aggressive alkaline pH of industrial degreasers and without the petroleum distillate solvents that commercial engine cleaners use to cut heavy grease, but that simultaneously attack the plasticizers in rubber compounds, causing the rubber to become brittle and lose its sealing compression over time. This is the mechanism by which commercial degreasers silently destroy your connector weather seals, not in a single application necessarily, but through repeated use over years, each application extracting a small percentage of the plasticizer chemistry from every rubber grommet and connector seal it contacts, until one day a connector that was once watertight admits enough atmospheric humidity to deposit its first layer of mineral oxidation on your camshaft sensor terminal, and your car starts throwing intermittent codes that take 3 diagnostic sessions and $400 to trace back to a connector that looks perfectly fine from the outside. Now, I want to specifically destroy the pressurized steam cleaning products because these are marketed as the premium solution for the serious home detailer, and they are in many ways the most dangerous tool you can use in a modern engine bay. The sales proposition is seductive. High temperature steam penetrates and dissolves grease without harsh chemicals. The heat sanitizes surfaces, and the pressure lifts grime that chemicals cannot reach. And all of that is technically true, and all of it is irrelevant to whether you should use it on your engine bay, because the problem with steam cleaning a modern engine is not chemical aggression, it is pressure driven moisture intrusion. The weather seals inside your ignition coil connectors, your fuse block connectors, and your ECU harness connectors are designed to resist atmospheric moisture and splash water from road driving, but they are not designed to resist a directed pressure stream of hot water vapor that is being actively forced through any available gap. High pressure steam follows the path of least resistance, and in a connector housing, the path of least resistance is the wire entry point at the back of the connector, and steam that enters a connector at the wire entry point condenses instantly inside the sealed cavity because the metal terminals inside are at ambient temperature while the steam is at over 200 degrees Fahrenheit, and that condensation deposits directly on the copper terminals in a confined space with no drainage path and no airflow for evaporation, which is precisely the conditions under which terminal oxidation accelerates fastest. The companies selling you steam cleaning kits for engine bays are selling you a product whose primary mechanism of action is incompatible with the primary design constraint of modern automotive electrical connectors. And they know this, and they have calculated that the time lag between your Saturday morning cleaning session and your first intermittent stall on the highway 6 months later is long enough that you will never connect the two events, and that lag is the entire business model. Here is the exact protocol for cleaning your engine bay safely, and I want you to follow this precisely because the sequence matters as much as the materials. Step 1 is patience, and it is non-negotiable. Your engine must be completely cool to the touch before you introduce any liquid to any surface in the engine bay. And I mean the plastic covers, the hoses, everything, because a hot aluminum intake manifold that contacts even a small amount of cool liquid experiences localized thermal shock that can stress the surface finish and in extreme cases contribute to microscopic cracking in the casting over time. So park the car, wait 2 hours minimum, and then proceed. Step 2 is preparation of your solution, which is a 16-ounce spray bottle filled with distilled water, available at any grocery store for under $1, with a single drop of mild baby shampoo introduced to the water, and you shake it gently to combine without creating foam because you want a dilute surfactant solution, not a foaming agent. Step 3 is the application rule, and this rule is absolute. You apply this solution to a folded microfiber cloth until the cloth is damp but not dripping, and you use that cloth to wipe down the exterior surfaces of your engine, meaning the plastic valve cover, the plastic intake manifold cover if your engine has one, the plastic coolant reservoir, the battery casing exterior, the smooth surfaces of the strut towers, and any painted metal surfaces that have accumulated light dust and road film, and you are wiping, not saturating, and you are working in small sections, and immediately following each wiped section with a second dry microfiber cloth to remove all residual moisture before it has any opportunity to migrate. Step 4 is dielectric grease application after cleaning. And this is the step that separates the people who understand automotive electrical engineering from the people who follow YouTube thumbnails. Because after you have cleaned the exterior surfaces and everything is dry, you take a small tube of dielectric grease, which costs $3 and lasts for years, and you apply a thin film to the exterior of each connector boot you can reach without disconnecting anything. And this thin silicone grease layer repels moisture, prevents ozone cracking of the rubber, and reinforces the weather sealing compression of every connector it contacts. And this single step does more to protect your engine bay electronics than any cleaning product ever manufactured. Now, I need to stop here and deliver the most important warning in this entire video, and I need you to actually pause and absorb this before you touch your car, because this is not a general caution. This is a specific mechanical hazard with a very precise and very expensive failure mode. You must never introduce any liquid of any kind into 3 specific locations in your engine bay, and those 3 locations are the alternator vent openings, the air intake tube opening if your air filter box is open or your cold air intake is exposed, and most critically, the spark plug wells. The spark plug wells are the recessed tubes in your cylinder head that the ignition coils sit inside, and they are surrounded by a rubber seal at the top of the coil boot that is designed to keep oil and water out of the well. But that seal degrades over time, and many older engines have wells that are not perfectly sealed. If liquid enters a spark plug well and pools around the base of the ignition coil, you have created a direct electrical ground path between the high voltage output of that ignition coil and the metal cylinder head. The ignition coil in a modern coil on plug system delivers somewhere between 20,000 and 40,000 volts to fire the spark plug, and that voltage needs to travel down the center electrode of the plug across the spark gap and return through the engine block ground. And when water is present in the well, that 40,000 volts finds a drastically lower resistance path directly through the water column to the cylinder head. And it takes that path instead of crossing the spark gap, which means the spark plug never fires, which means that cylinder never ignites its air-fuel charge, which means raw, unburned fuel vapor is pumped directly into your exhaust system with every intake stroke on that cylinder. Unburned fuel entering the exhaust system reaches the catalytic converter, which operates at temperatures between 800 and 1600 degrees Fahrenheit under normal conditions. And raw fuel vapor contacting a catalyst substrate at those temperatures undergoes a violent exothermic oxidation reaction that can spike the substrate temperature to over 2000 degrees in seconds, and a catalytic converter substrate that reaches 2000 degrees melts. It physically liquefies the ceramic monolith. And a melted catalyst does not just fail to function, it creates a physical restriction in the exhaust flow that can cause exhaust back pressure to build up and damage the turbocharger if your car has one. And replacing a catalytic converter on a modern vehicle runs between $800 and $2,500, depending on whether it is a direct fit OEM unit or an aftermarket substitute. All of that mechanical catastrophe traces back directly to water pooling in a spark plug well, which traces back to someone spraying liquid into the engine bay instead of applying it with a cloth. And the companies selling you engine cleaning sprays know that this failure mode exists, and none of them put it on the label because the label says to rinse thoroughly, and the liability shifts to you the moment you misapply their product in a way that their vague instructions technically did not specify. Compare that entire nightmare scenario to the $1 distilled water and baby shampoo cloth method, where the application technique physically prevents any liquid from reaching the spark plug wells, the alternator vents, or the ignition coil connectors. Because a damp cloth does not penetrate into recessed cylindrical openings under any application pressure a human hand can generate, and the worst case outcome of using a damp cloth incorrectly is a slightly damp plastic cover that you dry off immediately with a second cloth, and the engine starts and runs exactly as it did before you cleaned it, and looks factory clean in the process. The commercial engine cleaning industry has sold you the idea that your engine bay requires industrial strength chemical intervention, that the same environment that tolerates 30-weight motor oil and transmission fluid and brake fluid and coolant somehow needs a specialized solvent formula to remove road dust from its plastic covers. And that idea is the most expensive lie in automotive detailing, because the truth is that road dust and light engine grime are surface deposits held in place by nothing more than static electricity and mild hydrocarbon residue, and a mild surfactant solution applied with a cloth disrupts those bonds completely without requiring alkaline pH, petroleum solvents, or pressure, and the result is a clean engine bay that costs $1 in materials and $0 in diagnostic bills. Share this video with every person you know who is planning to detail their car this weekend, because the difference between watching this first and finding out the hard way is potentially several $1,000s and a car that runs perfectly versus one that is sitting on a lift at a dealership while a technician charges you $95 an hour to hunt down an intermittent camshaft correlation fault that you sprayed directly into your own engine on a sunny Saturday morning when you were just trying to take care of your